Okay, let's look at this problem. Okay, so Paige is vacationing in a cabin along the river. Okay? The path of the river near Paige cabin can be modeled by the function. So this is the path. You know, the river is moving like this, and this is the path. Y 116 x squared. Paige cabin in relation to the river is located at the point. This is the location of the Paige cabin. What is the distance from Paige cabin to the point 0, 0 on the lake? So let's look at one. He wants the distance from Paige cabin to the point 0, 0. The equation for that distance, let's just look at it here. A, the equation, it's the distance D. You have to look for these 2 points. This is Paige cabin to this point, and this is the Paige cabin at. So you're going to do 6, the x-axis, minus 0, square. Either way, you're going to do 0 minus 6 or 6 minus 0. Either way, because the square is going to take the minus out. And if you do the 6 minus 0, you're going to do minus 2 minus 0, the second one here. Okay? So you're going to do 6 minus 0 and minus 2 minus 0 here. So this is going to do plus minus 2 minus 0 square. And this 6 square is 36. And minus 2 square is 4. All under square root, and this is square root of 40, and this you're gonna, if you take 4, if you're gonna do it like this, 4 times 10, square root of 4, it's 2. So the distance, 2 square root of 10, and that is in, well, he did not show you if it's feet or meter. He did not give you the distance units. So you're going to leave it like that. There is no units here. So what's B? What is the distance from point this to Paige cabin? Okay. Now, the distance from here to the cabin. Remember, this is the cabin located here. Okay? So we're going to do it like this. Distance, this square root, again 6 minus 6 square plus minus 2 minus 9 over 4 minus 2 minus 9 over 4 square. Okay, and that's what gives you square root 0 square and minus 2 minus 2, and you just do it like 4 minus 8 over 4 minus 9 over 4 square, and that's going to be minus 17 over 4 square, and this is 0 square, and this would give you minus square is going to be positive, so it's going to be square root of 289 over 16, and that's the distance between the Paige cabin and the point here. Okay, what's next? Paige would like to know what the shortest distance from her cabin to the lake. Okay, where is the lake now? Okay, the short, what is the point to Paige cabin? The distance, okay, what is the distance from Paige cabin to the point 0, 0 on the lake? So this is 0, 0 is the lake. Now he wanted short distance between the cabin and the lake. Now we need to minimize. We need to minimize this distance. So we need to figure out a way. Let's just solve it here. So since this is very close, okay. Now, let's find out the shortest distance, which means that we need to minimize between 6 minus 2, which is this is the distance of Page Cabin, and the xy on the river. So the xy on the river is we need to find out that what is the point x and y that's going to be the shortest between Page Cabin to the river. So which means that the distance is the square root 6 minus x square, or either way, or you got to do x minus 6. Whatever way of doing it, that's going to be the same things. And plus minus 2 minus y squared. Okay, and that is the way we should do it. And now, the path of the river near the Page Cabin can be modeled as y is equal 1 over 16x squared. You put either one of them. Let's put the y here as equal 1 over 16x squared. So you could have it all y together. So this would give you square root 6 minus x squared plus minus 2 minus y. Minus y, which is 1 over 16 x squared. The whole thing is square. So this is the distance, or the shortest distance. And you could see here that the Page Cabin in relation to the river is located at the base 6 and minus 2. And of course, the cabin y is minus 2. And the y distance is, the y distance is 1 over 16 x squared. Okay, this is the minus 2 minus that, and that's, I think that's it. This is the shortest distance. So this is going to be the shortest distance between the cabin, the Page Cabin, and the river. That's it. Okay, let's look at number 3, or number okay, so that is, this one is a solution for the first one. This one is a solution for the first one. That's the relationship. The equation in part A is likely in terms of two variables. Use the equation of the path to the river y equal 116 x squared to get an equation in terms of just the x variable. That's fine. So now, when you do the distance, when you square both parts, distance square, that's going to give you 6 minus x squared plus minus 2 minus 1 over 16 x squared squared. And this is, you can see that this one is a function of 1x. Before it's a function of 1y. Here it's x and x. So this is the solution for number 2. Now, find the critical point. We need to find out the derivative. We need to find out the derivative to find out the critical point. So now 3. Let's solve this one. Let's solve this one first. What is 6 minus x squared? 6 minus x, 6 minus x, 36 minus 6x minus 6x plus x squared. This would give you 36 minus 12x plus x squared. And let's solve this one. Minus 2 times minus 2. This is minus 2 minus 1 over 16 x squared times minus 2, 1 over 16 x squared. Minus 2 times minus 2 is 4. Minus 2 times minus, it is plus 2 over 16 x squared. And minus this 116 times 2, it is plus 2 over 16 x squared. And then minus times minus is plus 1 over 16 squared x to the 4. Okay, 4 plus 4 over 16 x squared plus 1 over 16 squared x to the 4. So remember, 4 over 16, it's 4. So it's 4 plus x squared over 4 plus x4 over 16 squared. Okay. So now, so this is 1 over 4, x squared 1 over 4 plus 4, and that's, okay, that's it. Now, let's go down a little bit. So expand both, and now we will put it like this. The distance squared as a function of x, it is x squared minus 12x plus 36, this one, and then plus this one, x to the 4 over 16. What's 16 square? 16 square. 256. Okay, plus x squared over 4 plus 4. Okay, we have it like that, and now we're going to combine all the terms. So let's do it as x to the 4 over 256. X squared, this and this, it is, this is 1 and this is 1/4. So 1 plus 1/4 x squared, and this, there's nothing else but that, minus 12x, and then 36 plus 4, that's 40. And that is d squared x. Now we should differentiate. We should do the derivative of this as a function of x, d squared x. Now this one, you're going to bring the 4 down, so it's going to be 4 over 256 x3, and then you're going to bring this 2 down, plus 2, okay, 4, that is 5 over 4 x, and this is minus 12, this is the derivative of minus 12x, and that's 0. Now we're going to set the derivative equal to 0. So 4 over 256 x cubed. You want to find out the critical points. So we're going to set it to 0, the derivative to set to 0. 2 times 5, 10 over 4x minus 12. Okay. Now, if you multiply by, by 256 equal to 0, you're going to get you, or if you multiply by 64, all sides, 64, and that would give you x3 plus 160 minus 768 equal to 0. Now, this cubic can be solved numerically by trying a lot of variables. Let's try x equal to 1. You're going to keep trying until you find out the answer. If you put 1, it's 1 plus 160, that's 161 minus 7, no. If you put x equal to 2, try it. You will keep trying until you get to 0. So when you try x equal to 3, this is not going to work, this is not going to work. You're going to get, for example, let's just do it because cubic is very difficult to find an answer. If you try x equal to 1, you're going to get the answer minus 440. And that is not, it has to be 0. If you put x equal to 2, oh no, this is if it's x equal to 2, you get minus 440, and that's not the answer. If you put x equal to 4, you're going to get minus 64. Oh, you're coming close now. Let's do x equal to 6. Put 6 cubed plus 1/6 times x minus 768. And that would be equal to 408. Which means that the answer should be between 4 and 6. So the answer should be between 4.5 to 5.5. And approximately, numerically, the answer, the solution, is between 4 and 6. Okay? Let's look at the last one. If Paige walks the distance from the cabin to the river, at what point will she reach the river? Okay. Let's keep doing the critical. If you're gonna keep trying, you're gonna set x is equal to 4.8. Could you help me? You have a calculator? Oh, okay. Let's do this. 160 times 4.8 plus minus 768. 4.8 times 4.8 times 4.8. 3 times.
3 times?
Yes. One seat. Okay, 110.592. 160 times 4.8. 7. Oh, really? 160 times 4.8? Ooh. That's not going to be good. So not going to be 4.8 then. So it's going to be from somewhere from 4 and 6. Okay, so this is, I think it's higher than 4.8. Maybe it's going to be 4.5. You have to keep trying until you find out the variable of the x. Let's assume that x is equal to 4.8. That you're going to get equal to 0. This, yeah. Okay, so if you want to find out the exact point on the river, you should go and find out y. Remember the y in the river? It is 1 over 16 x squared. If you find this x that will give you a 0 answer, it's 1 over 16 x squared. 1 over 16. Let's see, if you say it's 4.8, and this would give you 1.44, and that is the critical value at x. So the point of the river closest by is 4.8, 1.44. So this is assuming that the x 4.8 is the answer. So the shortest distance, 4.8 minus 6 plus 1.44 minus y. So the things, it is, what is the value? Okay, so this is, it's 6 minus 2. The variable is 6 minus 2. So it's 6 minus 2. So we should do it like that. It is this one minus whatever value you're going to do, 4.8 minus 6. That's true. 1.44 minus minus. So this is going to be plus squared. So the shortest distance here is going to be square root of 13.3. So the answer is here, which is going to be the minimum distance at this point. So the minimum is 3.65 at a point equal 4.8 and 1.44.